Hello everyone, so in this video we are going into periodicity, variation of ionic radii. So we are going to focus on how we can explain the size of ions relative to its neutral atoms. Jadi dalam video ini kita akan tengok perbezaan antara ion dengan atom neutralnya. So here I have the comparison of atoms with its ions. So the orange ones are cations, the yellow one are the neutral atoms, and the blue ones are the anions. So if we look in period 2, so like that, so the one yang form cations are atoms of group 1, group 2, and group 13. So kalau kita tengok lithium, size 1.28, we can ignore the unit here because this is just a comparison. Jadi unit dia sama, so we don't have to worry about that. So lithium adalah 1.28, manakala lithium ion adalah 0.9. Kalau kita tengok beryllium, it is 0.96. Beryllium 2+, it is 0.59. Kalau kita tengok boron 0.84, 0.41. So kita nampak trend di sini. Okay, so we see a trend here that the size of cations, okay, so the size of cation is always smaller than the size of its neutral atom. Okay, and then kalau kita tengok anion pula, so contoh oxygen dengan oxide ion, fluorine dengan fluoride ion, sulfur dengan sulfide ion, chlorine dengan chloride ion. So all the rest follow the same trend. Kalau kita tengok ion, kalau kita tengok atom oxygen 0.66, oxide ion 1.26, almost double. Sama juga macam fluorine, almost double. Kalau kita tengok sulfur 1.05, 1.7, 1.02, 1.67. So size of an ion, kalau kita nampak di sini compare dengan atom dia, size of an ion is always larger than the size of its neutral atom. Okay, dan kalau kita tengok sini going across the period, so size of cation semakin mengecil, size of anion pun semakin mengecil. Size of cation semakin mengecil, size of anion pun semakin mengecil. So it follows a trend yang kita tengok dalam video sebelum ini. Okay, and as we know, kalau going across the period, okay, we can explain it in terms of effective nuclear charge. Manakala kalau nak compare ions dengan atom asalnya, so we have to explain it differently. Okay, so kita tengok dengan cation di sini. So kita ada magnesium. So magnesium, kalau kita tengok di sini, size of magnesium adalah lebih besar berbanding magnesium ion. Okay, kalau kita tengok di sini, magnesium punya electronic configuration 1s2, 2s2, 2p6, 3s2, manakala Mg2+, magnesium ion, it is 1s2, 2s2, 2p6. Okay, so 1s2, 2s2, 2p6. Okay, kalau kita tengok apa yang terjadi pada number of shells filled with electrons, number of shells dia berbeza. So kalau kita tengok magnesium, dia ada 1 shell, 2 shell, 3 shell. Manakala kalau kita tengok magnesium ion, it is 1 shell, 2 shell sahaja. Okay, so perbezaan number of shells dia berbeza. Okay, so when we look at the number of shells between atom and its ion, cation dia, number of shells dia berbeza, berkurangan. So daripada 3 shell, 3 shells, 2 shells. Okay, so magnesium ion has 2 shells filled with electrons compared to magnesium, which has 3. Thus, the outermost electrons in Mg2+ experience. So kalau kita tengok Mg2+ ni, sebab dia kekurangan number of shells, okay, perbezaan dia, number of shells dia berbeza, jadi it experience weaker electron repulsion, okay, ataupun shielding effect. Okay, Selain daripada weaker electron-electron repulsion, kita juga boleh cakap, okay, dia punya effective nuclear charge dia berbeza lah. But I don't want to explain in terms of that. It is easy using electron-electron repulsion. Ataupun dalam erti kata lain juga disebut sebagai mutual repulsion. Okay. Jadi sebab shell dia berkurangan, okay, electron-electron repulsion dia pun akan berkurangan, weaker. And as a result, the outermost electrons experience stronger attraction towards the nucleus, and thus the size of Mg2 plus is smaller, okay, than Mg atom. So this explanation is similar to going down the group punya explanation, cumanya perbezaan dia adalah kalau going down the group, okay, kalau kita go down the group, number of shell increase, manakala kalau kita buat cation, number of shell decrease. Jadi kita akan terbalikkan explanation dia. So this is the explanation for cations. So now let's focus on the anions pula. So here I take one example which is the chlorine atom. So the proton number is 17. So the electronic configuration is 1s2, 2s2, 2p6, 2s2, 3p5. Manakala Cl- pula, the electronic configuration is 1s2, 2s2, 2p6, 2s2, 3p6. Then here, the number of shells filled with electrons remain the same, but the number of electrons increases. Kita kena ingat, you have to recap back, okay? So shielding effect, okay? Shielding effect also occurs for electrons in the same shell. Jadi kalau kita ingat balik, shielding effect juga berlaku bukan antara shell sahaja, tapi dia juga berlaku untuk electrons yang ada dekat dalam shell yang sama. So kalau kita tengok dekat sini, 3s, 3p ni ada 7 electrons kan, so dia ada shielding effect. Kita tambah satu lagi elektron, dah tentunya shielding effect dia makin kuat. So Cl has more electrons than Cl atom, thus the shielding effect ataupun electron repulsion ataupun mutual repulsion, pilih salah satu je, increases. Okay, so the electron repulsion increases, and as a result of that increase in electron repulsion, the outermost electrons in chloride ion experience weaker attraction. Kenapa dia weaker? Sebab dia elektron dah tolak-tolak, jadi the electrons are being pushed away. Okay, so it is being pushed away from the nucleus, jadi they experience weaker attraction towards the nucleus, and as a result the size of Cl- is larger than Cl atom. So that's pretty much it for the comparison between cations and its neutral atom and anions and its neutral atom. So I hope you understand this video. So again, if you have any question regarding this, please feel free to ask me, and you know where to find me. Thank you very much.